earlier this week we chatted about growth and decay, and we had some basic portions of the parent function. What you're going to notice here, because we mentioned yesterday that growth and decay and logs are inverses, they're opposites, that what you're going to see on this little mini list here is a whole lot of things that are the opposite of what we did earlier in the week. Because now it's still continuous and still one-to-one. Okay, there's the similarity. Once we get past there, your domain is the set of all positive real numbers. In other words, now your domain starts at 0. It goes to infinity when we're talking about logarithms. Because the y-axis is now your asymptote. So now the asymptote's going vertically instead of horizontally when we're doing pictures of these. And the range is all reals. The range is now infinite. Everything is just literally flip-flopping. And the graph contains the point 1, 0, which now is an x-intercept instead of a y. So it's like everything you learned earlier in the week, just flip it on its head and you have a logarithm. So, do I have to know that off the top of my head? No, but it's nice to kind of know the graph that you're putting in looks right. So, with that in mind, now we'll go over to page 9 and kind of see what we got working here. You're like, oh, not that again. Yeah, H and K back for another session. Nothing too terrible. Again, just some reminders, but before we get to those, we're going to take a peek here. Let's make sure we're all looking at the same graph first. So if you could do a Zoom standard, a Zoom 6, just to make sure that you don't have some funky graph from yesterday left over. Oh. Like that. Okay, we don't need that. Y equals, clear that out. We want the log of x. There's log right next to 7. Log of x, we'll close that up. Let's just take a peek. Okay. First thing I need to mention, and I'm going to mention this a lot as we go through this lesson because people screw it up too much. Otherwise, thank you. So, what I'm going to mention as we're doing this, as I'm rolling these around, is that it looks, at first glance, when you look at this graph, it almost looks like a square root graph. You're like, oh, it starts there and it goes. This line is continuing to get right along that y-axis and just hug it and keep right on going. So that doesn't stop. That keeps going down and down and down forever. So don't get fooled by what you see on the picture. There's more to it than that. So, second graph. Let's get some points here. There's our error messages. Man, it looks a lot like a square root function. Right up into where our asymptote is at 0. So let's see what other points we got here. We got 1, 0. Do we get any other whole numbers here to play with? We do. 10, 1. You're like, well, 1, 0 and 10, 1 is not a whole lot to work with. That's true. But with knowing that our asymptote is at 0, because that's where the first error message is, we'll go ahead, we'll get that drawn in here with it. And this graph is not going to stop right there like it looks like it on our calculator. It's going to keep right on going up real close to that asymptote. Excuse me. Thank you. So, our vertical asymptote is at x equals 0, not just 0. We really got to be specific since we have growth and decay ones too with y equals 0. Our x-intercept, which occurs when y equals 0, is 1, 0, just like we said back on page 8 before we started. And just a quick reminder again with the transformations, I know at this point this is getting old, but that's okay. H is our left and right. Again, the opposite of what you think. It says right there, minus opposite. Our K, just like it has been, is up and down. And now at least we've got a picture to look at as far as domain and range go to help us remember how this works. This graph definitely is not going left forever. You've got an asymptote in the way saying, stop, hold on, you're not going any further. So from that asymptote, okay, these two are going to have a direct connection every time. Your domain is going to start where that asymptote tells it to and go off to infinity to the right. The range goes down forever, and I know this looks like it's just going sideways, but it is gently going upward still. So your range always on logarithms, just like your domain was always infinite on growth and decay, on logarithms, it's going to be your range is always going to be infinite. And that covers this on our basic stuff, okay? On a basic base 10, because I don't see any little number down here in my base log. So if you want to have a quick way of doing something, if you're just doing a sketch thing sometime, okay, if your base is greater than 1, like in our one up here it was 10, you can use the points 1 over b, negative 1. So actually up here, there was 1, 0. My base was 10, so there's where my 10, 1 was coming from. And if I wanted to, the calculator doesn't tell me this because it's a fraction, but there also would be a point at 1/10, negative 1. Now, do I have to have that 1/10 negative 1 to make my graph? No. But those 2 points and knowing I'm hugging the axis is going to help. If the base is less than 1, these points are still here, but they reverse, okay? You could still write them all down. The order isn't going to matter since they're identical. It's just going to look more left to right if you're doing a fraction with these. Then apply transformations. Now, this is me. Just me, okay? I am more of a fan, since you have technology available, I would rather use technology on these. If I have a base 10 log, doing this is simple. I can do that. Once you start changing bases, especially once you start doing transformations, I think it's going to be easier and more time efficient to use the tech. But I'll still show you both because that's what I normally do anyway. So let's move up a little bit here. Okay. Log base 2 of x. If I'm just using the rule up here, okay, and I'll do that to start. So since my b value is 2, my points would be at 1/2, negative 1, 1, 0, and 2, 1, because my base is greater than 1. I'm just following those rules. Those 3 points, if I don't have any shifts, that is quick. So at 1/2, negative 1, 1, 0, and 2, 1. Now this stinker is going up in a hurry. We're still hugging. And we're off and running. Since there were no shifts left or right, my asymptote has not moved. We're still hugging right along here. Vertical asymptote, let me move this up a little now, is still at 0. And I may have made that slightly too steep, but we're about to find out. Range is the free square with logs. And there's always that direct connection between your domain and your vertical asymptote. All the patterns are here. And my x-intercept, especially if I do it with the points, is always going to be where that y value equals 0, which is going to be at 1, 0. You're like, okay, I like that. That was kind of cool. But if you were going to go to the calculator, okay, what's that going to look like? So let me jot, where do we want to jot this? We're going to jot this right here. If we're going to go to the calculator, okay, I'm going to do a generic form of it here. We'll write it out down here. Okay, so if you have a generic logarithm like this, I could have called that x, but I'll just call it a for right now. What we're going to do in our calculator, we're going to put in the log of a divided by the log of b. This is called change of base, okay? The calculator doesn't naturally do it. Yes, there are some buttons that you can press on there, but I would prefer, and I'm going to show you, if you get creative and figure out other things, you can. I'm going to show you how it would work on any calculator, or how back in the day, here it comes again, that we used to do it. So, if I want to do this one on the calculator, I'm going to go to y equals, and I'm going to do log of x, close your parenthesis. You've got to remember that to close that piece off, and divide it by the log of your base, which in this case is 2. So if I do that, I'm going to look at the picture here first. Ooh, I was pretty accurate with my graph. Okay. So we notice it stretches up higher and quicker. If I pull my chart, there's 1, 0, there's 2, 1. I mean, I even get a little bonus. I get 4, 2, and 7, 3. So my graph would probably be more accurate than the one that I made. Yeah, I got a little too steep, but not too bad. So there's the advantage that you are going to have. And also, if you tend to forget things like the asymptote, the calculator is going to give you a reminder, hey, the asymptote's at this first error message, it's at 0. That's doable for every problem you do with these. So you have options when you're looking at this. Next one, same thing. We'll play both ways one more time. This one, I'm not putting you through the panic. So here, this time my base is less than 1. I'm just going to switch the order I'm doing these points in. And you'll see in a minute why we would do it this way. It wouldn't hurt if you did it with those, but 1 over b, be careful. 1 over 1/4, move my fingers out of the way. 1 divided by 1/4 is what? 1 divided by 1/4 is the same as 1 times 4, which is 4. So 4, -1 would be my third point, if I'm doing it that way. Again, that's going to be your call on something like this. Well, what if I'm doing it in my calculator? Okay. We're still going to have log of x starting, but we're going to finish with log of 1/4. So let's see here. Let's take a look at the picture. Ooh, it opens downward. Okay, we kind of saw that here. So here come my points again. 1, 0, 4, -1. Now, if you want to grab an extra point here, I don't know, like 8, -1.5, that's cool. But remember, do not stop your graph there. Don't do it. Don't do it. We're hugging that asymptote. We're hugging it tight. Just don't cross it, man. You cross it, it ain't going to be happy. Asymptote, domain, they're buddies. Range just doesn't care. It just does the same thing all the time. And my x-intercept still hasn't moved. It still ends up being in the same place. Well, what's going to make a difference on that? You're going to start seeing an x-intercept change if you're moving left or right. If your asymptote moves, your intercept is going to move with it. Not directly in tandem, but they're both going to move. So, oh boy, We get to the last one. And again, if some of you want the pain of figuring out all the transformations that you would have to do on 27, I will show you individually. Otherwise, here's what this one is going to look like in your calculator. And I'm literally going to write this one out because this one gets a little complicated. I need to keep this piece separate from the rest as I'm doing this. So when I'm putting this in my calculator, we're going to start with the 2, but then we've got to say, okay, we do the 2 later. Right now, I want to do this logarithm. So this part, we're going to have log of x plus 3, close my parenthesis, divided by log 4, there's my change of base. When you close the parenthesis on your log, you need a second parenthesis because now you close the log 4, now you're closing the entire log. You're saying, okay, this stuff is together. And then I can put the -2 on the end. So any transformations besides your left or right, if there's a number in front, if there's a number at the end, they've got to be outside of the log. Otherwise, this doesn't work. And you've got to go through the other pain. I don't want you dealing with the other pain. So once we get all that taken care of, let me get it back in the screen here. Okay, let's take a picture. Take a look at the picture here. So check it out. We moved what directions? Let's see here. We went left 3, and we went down 2. Now, did that equally mean up 3, down 2, we started there? No, but it told us a couple of things. What did it tell us? First of all, it told us the asymptote has moved. It's now at -3. So, asymptote, do not cross line, is now at -3. Check out your other points, okay? -2, -2. Just as an FYI, if I move 1, 0, and I go left 3, that's -2. And I move 0 down 2, that's -2. Huh. How coincidental. -1, -1. 1, 0. I'm going to go ahead and take all the points I can get here. I'll take all the help I can get in making this accurate. So hug that asymptote. Do it, do it, do it. Okay, off we go. And all the information that I need, I already have, basically. So I know the domain and the vertical asymptote are buddies. So -3 to infinity. Range still doesn't care. Range is like, that's nice. You shifted a bunch of stuff. Don't care. It's infinite. And my x-intercept, that's the one shocker maybe. My x-intercept didn't end up moving. It's still at 1, 0. Just the way that things move. So that's the fun part. When you have to deal with the shifts, that's not as much fun, but it's still palatable. Okay? And you're like, wait, that's it for the note? That's it? That's it. So, reminders on a couple of things before some of you get too far. Reminder number 1, and I'll put it back up on the screen in a minute. Get into classroom, people. Get in there, okay? You have too many tools that you need to not be in there at this point. So, I'll get that back up in a sec. You kind of knew what was coming here. Page 14, the last page in your practice packet, is where the practice is at for these. So play with these. I don't know if I'd say 3 of them is going to be enough. You're going to have to make that call. But it's good that no matter which way, you're going to have to deal with a crazy problem. That's good. That's a good thing. So, again, I have keys to evens up here in front if you want to go that route as you're looking. And be working on your preview. Do not wait until Monday and then be like, I don't know how to. Start figuring this out so we can really get after it and get going, because we got all the things now. Yep, Monday is all questions on preview / workday. Tuesday is the quiz. All right. So